Hello, welcome to our webinar series yet again. Today I'm joined by Rafał. Hi, Rafał.
Hello.
And we are going to talk about migrating from Apache Solr to OpenSearch. This is one hot topic right now. We are actually seeing quite a lot of heat and quite a lot of discussions about this topic. And I'm eager to kind of see what Rafał has to talk to us about this today. Just as a quick reminder who we are, we're BigData Boutique. We have tons of experience with search engines in general. So going back 15 years, Elasticsearch, OpenSearch, and obviously Solr. We are partners with both OpenSearch, now under the Linux Foundation, the OpenSearch Foundation, and AWS. So we help customers to run, migrate to optimize and support their OpenSearch clusters anywhere on AWS, on any other cloud than self-managed. Myself, I'm an OpenSearch ambassador, one of 11, and ambassadors are now accepting additional people who would like to join, and you can definitely send your applications. And we have tons of experience with working with customers on those, either migrations or optimizations, new workloads like vector search, Gen AI, and we'll talk about those as well in just a bit. To set the scene, we actually are getting more and more asks from customers worldwide to help them with potentially migrating from Solr to something more modern. And a good candidate for that is OpenSearch, because OpenSearch and Solr are pretty much sister projects. They're both using the same core, and Rafał will talk about that. And then basically, it's often quite an easy migration compared to others. We just completed a project with yet another customer, Alami, based out of the UK. They are a stock photography agency. They allow you to search on photos and videos and other image materials. And they have a really, really large collection, and they were based on Solr. When they wanted to modernize and migrate, they looked at OpenSearch, and we effectively helped them migrate from Solr to OpenSearch, keeping very high scalability and performance requirements. It was a really interesting, really challenging project led by Rafał as well. And we are now working with them on reviewing some additional opportunities, looking at advanced capabilities of OpenSearch to extend this further. And this is a great seg for the actual session that we have today. And without further ado, Rafał, the stage is yours.
Thank you, Itamar. So, hello everyone, and hopefully you can hear me good, and hopefully we'll have a great time together. So if you'll have any kind of questions during when I will be talking, I like talking, by the way. So, I can talk a lot, but please interrupt me. Itamar will will post the questions on the screen, and I'll answer them as soon as I finish the sentence or a thought or something like that. So please don't hesitate, just write, and we'll manage them during the webinar. So a few words about me. I'm a father, actually, of an almost 18-year-old male and a bit younger daughter, though, kind of fun. I'm a software engineer by graduation and still working as a software engineer and an Apache Solr, Elasticsearch and OpenSearch consultant. I've been involved with Lucene and Solr, especially with Solr since the version 1.2, more or less, I think. So it's been, I would have to calculate, but more than 15 years, I think, right now. So that's the thing. And of course, starting from Elasticsearch when it was pretty young, still not very popular, but just something that grew up and was a new kid on the block. I'm also a trainer, so I try to share the knowledge that I have about those search consultants, about those search technologies. And finally, I try to also share the knowledge on the conferences. You can see me almost on a regular basis on, for example, Berlin Buzzwords, but I try to be wherever I can if I have anything interesting, at least from my perspective, to share. And finally, I wrote a few books, but it's been a while and probably outdated already. So yeah, that's about me. And the agenda for today is pretty simple. We will start with a strategic view over what's the vision and key benefits, why we want to migrate potentially, what is the status of search in 2026, and we'll talk briefly about the feature gap of those two, right? What are the release cycles and so on. And then the second part of the webinar is moving into the technical tutorial. So how to plan the migration, how to execute, what steps you need to take in order to properly migrate from Solr to OpenSearch and not to run into issues. So if the migration should be smooth, shouldn't affect your business, should be as invisible for your users as possible. Maybe in the end, they should see improvements in latency, quality, and so on and so forth. However, during the migration, we shouldn't affect the business. After all, the business pays the bills, right? So that's the thing. So let's start. Why are we doing this? So looking at those two projects, we have a few things that we can mention. First of all, we can mention the development cycle. However, we like Solr, we like OpenSearch, right, and so on and so forth. I'm a Solr guy. You can imagine that, but we have to admit that we have a bit more active community on the OpenSearch side. Like a bit, that's understatement, I would say, at the moment. In addition to that, we have a slightly faster release cycle on the OpenSearch side. We'll see about that. It's more cloud friendly. Just from its API construction, it was designed like Elasticsearch initially was designed to be distributed from the ground, let's put it that way. So it starts and works in a cloud mode. In Solr, things were different. It started with this, it used to be called master-slave, now it's a leader-follower architecture, and the Solr cloud was there, introduced in Solr 4.0. That was a completely different mode that you have to start, Solr cloud, and so on. And in addition to that, if you want to focus on your business and not take care of the infrastructure and take care of managing the service, taking care of the patches, and so on and so forth, so OpenSearch does have managed services available for convenience, and in many cases, this is something that you just can't ignore for the operations. IT is not cheap, let's be honest here. And if you can not care about the infra to some extent, that may be a big game changer for you, because, for example, your IT department may focus on building those business features rather than maintaining the infrastructure that is used to power your business. So this is also a big plus on that side. So looking at the landscape, this in the beginning of 2026, let's compare those two. We have the latest stable release from Solr, 9.10, with 10.0 almost around the corner. There is right now a voting. It should pass soon, and probably we will see Solr 10.0 with new shining features, but it's still not here. At least I checked 3-4 hours ago, and the release was not still there. The latest stable from OpenSearch is 3.4. Not that far away from each other when it comes to the dates. November, December, the same year. However, the release cadence is slightly different. We have around 2-3 major releases, like 9 point something release from Solr, and we have 4 to 6 releases a year from OpenSearch, at least on average. We have a bit higher community. The community for Solr is quite dedicated, but smaller, stable, doesn't grow or doesn't like shrink that much. But when it comes to the community on the OpenSearch side, we have more than 200 contributors at the moment. And of course, we can't ignore the fact that Solr is, of course, Apache Foundation based. So, the community over code and so on, it's nothing bad. It's really great. On the other side, we have a commercial entity behind OpenSearch. So we have Amazon there that does take care of some of the things about OpenSearch, and they actually run business on that because they do provide service like managed service. So they want that to grow. So at least but for foreseeable future, we may expect OpenSearch to grow and expand rapidly, and we've seen that. So that's something that we can easily expect. When it comes to the search itself, it's changed as well. If you've been with search for some time, thank you, Itamar. By the way, it's OpenSearch. Just to mention, it's in the OpenSearch Foundation. That's true, backed not only by AWS itself, but also IBM and so on. So yeah, thank you for the correction. I tend to forget about it. Yeah, so thanks a lot. Getting back here, we're kind of, let's put it that way, in a hybrid search era. Keyword search is still good, and BM25 and the companions around it, so based on the term frequency and inverse document frequency, are still around. They are not gone. And in some use cases, this search is pretty strong still, but customers and their users want more. They want semantic understanding. They want RAGs. So the new kid on the block, not new, but a buzzword around. You can hear AI, RAG, and so on and so forth. And this is what we need to think about in order to stay on the market, at least as the providers of the search solutions and systems that are powered by search. So we no longer search, for example, for a castle. We want the engine to understand the nuances of the search, to be more intelligent, and so on. And that's where those vector functionalities from a search engine comes in. And of course, we don't want our users to wait for those queries to be executed. We want them as fast as possible, as cheap as possible, and on as large document base as possible to provide, the latest, the greatest features and the greatest search experience for our users. So that's the king. And of course, agents will query our search engine semantically, not necessarily using keywords as we would expect from the users, the human users. We are all pretty used to using keywords. Google taught us that for some time, but right now people are, when using all this chat AI related, start to use natural language to express their searches. They are pretty good at that and expect the search engine to understand that's and so on. And when mentioning that, keep in mind that we do have the Beyond Keyword Search Modernization with OpenSearch by Itamar. So have a look at that. Pretty good, I would say. I really recommend that. If you have time, go for it, look into that. You can find that on BigData Boutique website. The links are there. So Solr versus OpenSearch, the feature gap. Let's go and see what are the differences, at least, to some extent. Of course, we don't have time to cover everything, but some of the things we can talk and hopefully learn a bit here and there. First of all, as we already mentioned, we have two, like in Solr, we have two run modes, basically. The distributed old-fashioned, the distributed, the Solr cloud, which with Solr 10 will be the default. But right now it still is not. And the old-fashioned leader follower, where you don't have the real-time or near real-time, I should say, behavior, but physical copy needs to happen on a regular basis with some delay and so on. It's still usable in some use cases. Think, for example, very static index, like data indexed once every 12 hours or something like that. Then Solr can really shine when it comes to performance there because of its static global caches. But apart from that, the delay is in most use cases unacceptable. When it comes to OpenSearch, we have distributed by default, starting from the earliest version of Elasticsearch. It grew, and all the features are written with distribution in mind. Some of the features in Solr are not. We have to be aware of that. They are being rewritten, some removed with the different Solr versions, but still you can end up on and hit quirks here and there. So it's good to know. They are both JVM based. So, Java for the win here. And both use Apache Lucene as their full text search engine library of choice. So they build up on that. When we hear shards, when we hear segments and so on, this is all because of how they are leveraging Lucene under the hood. So starting from the very beginning, they were both built on top of that great library and still are. So yeah, Lucene is still here. I think one of the kings or queens, I don't know actually, of the open full text search world. Let's put it that way. When it comes to the differences, of course, everything else is different. The queries, of course, you can expect both Solr and OpenSearch to mimic what Lucene provides when it comes to queries. So, Boolean queries, something like range queries, and all of that flavors of what you can expect from a full text search library. But on top of that, you have some APIs that they provide. For example, Solr right now have two APIs. I would say old-fashioned, though the first one is old-fashioned, the URL-based. So you just put the parameters in URI and push it to Solr, and it returns results, right? Those of us who worked with Solr are kind of used to that. But Solr also has this JSON API that allows you to do the same things with it. And the notion, one thing I should mention is the notion of multiple parsers. For example, one that is commonly used is the Dismax, so extended Dismax parser, that you just push the params, you push the query, and it does the magic for you. It takes the query, it takes the query fields, it does all the disjunction max queries, and so on and so forth, and returns the results. In OpenSearch, things are a bit different. We have a fully, JSON-based query DSL that allows you to structure the query pretty well, to tell OpenSearch what to actually you want to search for, and so on. You have the queries that are mimic the Lucene queries in the DSL, and of course build on top of that to give you that high grade of control over what behavior you want from the search side. Some people tend to like what Solr provides. Usually, those guys or girls who actually worked with Solr for some time and are not very keen on a bit more verbose language that you need to use when it comes to talking to OpenSearch. But OpenSearch, at least in my opinion, gives you slightly better control and it's easier to read, especially when you are not that experienced, for example, with the search engine. You can expect what is happening there. So I would say what is better, it differs. It's a matter of taste to some extent, but new people that come into search world tend to like JSON better. So just a fact, talking to people and so on. When it comes to analytics engine, we have in Solr, we have those old-fashioned facets that allows you, for example, to get counts of on top of the documents that you have returned in your query. So if you run a query, you can get number of documents per category, per author, or whatever, based on fields, based on queries, and so on and so forth. And also you have like hierarchical support and streaming aggregation in Solr Cloud that allows you to do a bit more sophisticated calculations, not a bit, but sophisticated calculations, but in a slightly different approach. So you no longer like run queries, but it's more of a streaming engine. When it comes to OpenSearch, we have aggregations with, I would say, almost virtually unlimited nesting and domain change. So you can select which documents you want to actually calculate the aggregations on. Take term aggregations, so get the top authors. On top of that, calculate how many posts and how, what's the average, let's say, number of stars per post, and then do another grouping and so on. Virtually anything. You're only limited with your compute power and memory that you can give to OpenSearch to calculate that. The more complicated the query, of course, the more compute power you will need to do that live, because actually those calculations are done in both cases live. They are not pre-computed, of course, apart from some of the data structures on the disk that are created during indexing, but apart from that, things are very dynamic there. So keep that in mind. I would say if someone would ask me which search engine provides you a more like out of the box, more sophisticated analytics option, I would say OpenSearch at this point. However, don't quote me on that, right? But I think that's true, because you have more aggregations on top of your data that you can use, and then it's a bit easier compared to structure more sophisticated calculations. Let's put it that way. You can, for example, see all this software that is based on OpenSearch aggregations that allow you to work with metrics, logs, etc. It didn't happen. It did happen for a reason. That's for sure. Okay, the differences, right? When it comes to the data organization, maybe we should start with that, but let's touch on that topic as well. When it comes to data organization, things are different and similar. Of course, at the end we have Lucene index. In the bottom. Let's stop there. However, Solr uses collections, which are divided into shards, so physical Lucene indices, those shards, and you can have a collection built of primaries and replicas, so physical instances of the index. In OpenSearch, we have indices that are as well divided into shards, so you can slice and dice your index or collection, whatever we call it. This is more or less the same, a virtual entity that groups shards together, and in most cases, in all cases, like shares the same configuration over the data structure and some additional settings that you set, right? So, for example, you may have an index or collection holding your pictures or users. And because of how large it is, you may shard it into multiple smaller pieces to parallelize the processing of indexing and querying. Or you can, for example, create more replicas to allow for higher throughput of queries if you are fine with your per shard latency of the queries. In terms of shards, things are not that simple. You don't have one type of shards. Solr actually allows you to, especially like talking about the replica shards, not the primary, because when you have primary, it's one type. When it comes to replicas, Solr does have 3 types: NRT, TLog, and pool. They differ in how they manage the replication of the data. Some of them are designed like the NRT one, so near real time, is designed to be working with this as small latency between the update and when the document is happening to be visible to search as possible. However, it comes at the price of the hardware that you need in order to keep up, right? So you need to be constantly indexing, refreshing your shard view, and so on and so forth. And sometimes you don't need that. You don't need the NRT behavior. In that case, the TLog and pool ones come in handy. The TLog pulls that so-called transaction log in Solr, which is a write-ahead log file that writes the data first, and then it's indexed. Not to get too deep into the technicalities here, but it allows to save some, let's say, resources, hardware resources, and only pull the data from time to time. And finally, there are like pull replicas that allow you to just pull physically the segments of Lucene, which is the least hardware demanding, I would say, if I can say that, but of course comes at the price of a delay over indexing. You can think about it more or less a leader-follower architecture on top of Solr Cloud, and you can mix those. This is pretty awesome. From Solr side, you can have NRT replicas, you can have TLog and pool configured for a single collection, so we can divide and conquer your data depending on your needs. In OpenSearch, we have document replication and segment replication there, and also, which is awesome, one of the things is the S3 stored backed one. So you put the data there and they get it when they need. It's awesome if you have like a cold storage. Think about it like this: when you don't need all your data to be available real time, you need it from time to time on a request, so you don't need to spend up like all that memory, because I didn't say about that, but an open shard, an open index or collection requires some amount of memory to be kept alive. So if you can put that in S3 and save that, you may end up having like way larger amount of data that is actually living inside the cluster and be able to work with that. This is pretty awesome if you like, if you would ask me. When it comes to leader election, I would say OpenSearch wins with simplicity here. You don't need any kind of external software here. You have the built-ins and discovery. You configure your cluster, and it works more or less, right? If the network is visible, if you don't have any kind of issues with that, it works. When it comes to Solr Cloud, you need Apache Zookeeper, so it does require an external software, also JVM based, and in order to be fully fault tolerant, you need 3 of those at least. So to be able to handle any kind of upgrades, breakage, and so on. And as we all know, software will break. It's just a matter of time when. So we have to be prepared for that. So here we have to remember about that. There are also kind of like the other differences, like transaction log, which is required for Solr Cloud. On one hand, it's an awesome thing because this is a write-ahead log, and Solr behavior is that it can catch up from the transaction log when the replica falls behind a bit. The last, I think it's 100 100 entries in the transaction log. But apart from that, it's yet another thing to take care of. We have Lucene segment based in OpenSearch, And recovery behavior on those two depend also on the replica types, especially in Solr. So depending on which type the replica is, the recovery is designed the way the replica is. So for NRT, it will try first to take the transaction log, then the physical copy of the segments from the given shard. The pool, T-log and pool, of course, are different. When it comes to OpenSearch, this is binary data from replicas. If you worked with Elasticsearch and OpenSearch, you may see something like recovery and copying data between like shards and so on. This is part of the recovery mechanism, a full binary copy of the smaller pieces that the shard is built of. So-called segments, immutable data structures, more or less immutable. I'm lying a bit here, but for today we can assume they are immutable, right? So that's how it goes. And of course, the biggest, I think, one of the key differentiators here, at least in the current versions that are released, is the differences with the dense vectors and in general all the vector search related stuff. So we have the various algorithms supported by Solr, similar to by OpenSearch. However, we have the FICE and maximal marginal relevance in case of OpenSearch. The MMR, I think, was added in 3.3, if I recall correctly. And those are set to be really, really performant, and we can see that the performance difference is large, and I think in the docs, at least I can say from the docs, you have keeping 90% of the relevancy while improving the search performance 100 times. So a big improvement in vector search on the OpenSearch side. Basic support on the neural sparse search on the Solr side requires external embedding service and pushing the data during indexing. We have on OpenSearch, of course, the seismic fast algorithm, as I mentioned, providing up to 90% accuracy with a very, very good speed. And of course, both of them provide some degree of control over the behavior and support from, especially on the OpenSearch side, support, for example, for quantization and so on, which depending on the size of your data and the vectors that you build, that your model output, may be a big difference, and so on. And again, if you have questions, write them up. I'll try to answer. I don't know everything, but if I know something, I'll be happy to help with that. So let's get into the technical part of the webinar, so tutorial on how to do it. First, we have the planning and discovery phase, right? Because we just can't go into the execution without knowing what we actually aim for. And the thing that I think we all should be aware of when it comes to all this execution phase and planning is that we need to, first of all, do the technical planning. So analyze what we are using currently, what's our indexing, how the document look like, what's our user behavior, how our queries look like, and so on and so forth. Pure technical stuff. Let's put it that way. But on the other hand, we also have our team that needs to be prepared for the migration as well. So we have our engineers that may not know OpenSearch. They may be used to Solr and so on and so forth. So we need to prepare the team as well to teach them on how to use this new technology and allow them to get used to it in order not to run into issues like the basic stuff, and so on and so forth. So basically 2 parts. We need to remember about technicalities, but also keep in mind the team preparation and learning. I'll skip the second today. When it comes to the planning, what I like to start with usually in terms of those technicalities is analyze the current behavior of search. So we talk about the short counts and so on. It tells us what's the current requirements for the our Solr needs, right? When in the end, how many shards, what's the target latency, and so on. How did your JVM heap is allocated per Solr node? So what are the memory requirements? Of course, those two, the search engines differ. OpenSearch differs when it comes to the amount of memory that it needs. However, not that greatly, because underneath, as we know, there are Lucene that has its own requirements on memory. Not a lot, but still, that's one of the things that we need to note first. We need to, of course, note the indexing rate, query throughput, and so on, the basics. Then analyze the configuration. What's the analyzers? What's the tokenizers and filters? So how our language analysis is defined. We need to mimic that in our OpenSearch configuration. We need our update request processors to be documented. We don't have update request processors in OpenSearch. We need to somehow migrate to a different functionality, still providing us the same or more features on top of the search engine. Custom query parsers, if there's something that we use. Are there any plugins that we use on top of Solr? Maybe we need to move them as well. Or maybe OpenSearch already provides us with enough out-of-the-box features that we may omit custom code, which would be beneficial for us, as custom code always means that we need to take care of one additional thing or multiple additional things if we have multiple plugins before doing an upgrade. And there may be changes and so on. Finally, identify dependencies, which is, I think, sometimes overlooked when we are talking about migrations. We are migrating not only the search engine, but also the applications that use the search engine needs to be prepared for that. So, everything that uses, for example, Solr.j will need to be modified to use either a HTTP client to shoot directly to OpenSearch, or use a library and OpenSearch client and a library that will allow us to talk to OpenSearch. We need to, of course, configure any kind of admin scripts and so on to be updated to the behavior of OpenSearch. The APIs are completely different. The behaviors are different. So we need to account for that. And finally, authentication, authorization needs. On both sides, we have the options to set up security, and it's usually more visible from the OpenSearch user side because when you download the default package, if you don't go for minimal and so on, you're probably exposed to the authorization right away. It's not that easy in Solr, and you're not exposed directly. You have to at least configure it a bit. So, but if you are using any kind of authorization on Solr side, you will need to migrate that and note your needs, document everything, and migrate and configure it on OpenSearch side, which I think shouldn't be a problem. You should be able to do that without any kind of issues. And then the strategy for migration. I usually start small, like the POC approach, right? So let's do a small proof of concept that usually starts with the one representative collection, something that allow me and the customer to talk about a normal use case. In example, let's search for photos. That's a use case that the mentioned customer is doing on a regular basis. And let's take this part of the data, maybe not everything, but part of the data, or if we can, if the data is if it's doable from a resources perspective, we can take all the data, create the configurations and so on, run some production traffic, observe, test the most complicated queries first, because they usually expose kind of an issues that you may hit. Translating the queries one-to-one may result in not optimal performance because, for example, Solr has this top-level caches. Some filters may behave differently when it comes to performance and so on. There may need to be changes that will have to be done to the queries. So it's usually good to test those representative queries. And by most complex, also, I think I should add the point here that you should also take your representative queries, as I mentioned, the ones that bring you or are most common for your users or bring you the most revenue when it comes to, which is pretty common in like e-commerce world, right? The e-commerce people know what their people are searching for, what their users are searching for, what are the needs and so on. Test that. If possible, create automation to validate your changes. So, do this test, do A/B testing, validate manually, validate automatically. The more validation you will do, the better. Because you will end up with some discrepancies, that's for sure. It's the usual case. It's just a matter if those discrepancies are acceptable because, for example, you end up with a better search experience, which will be awesome. However, sometimes you may need to adjust queries here and there. And keep in mind, observe, don't just shut down Solr, observe the differences between the systems. You may also end up, running A/B testing between those, and that's also a good idea. When it comes to the next step, you will need to migrate your configuration. You usually start from migrating the schema. I really encourage you to go to this blog post on a BigData Boutique blog, and there is a script also actually that will help you. I didn't say that. I like to do that manually, but if you would like to do it, go there, check that out. In general, you will need not only to migrate, just take the schema and translate it directly, but as you can see, there are changes that needs to be done when it comes to, for example, field type mapping. So things like p or tint are need to be translated into integer and so on and so forth. There are changes. I think only Boolean is called the same. The others are not. You will also need to think about and a bit shift your mindset when it comes to the configuration itself. Stored indexed is not the same. Stored in Solr is stored in OpenSearch, and so on and so forth. Doc values are written different. Multi-valued are enabled by default in OpenSearch, and copy fields are like copy to, and also you have the notion of fields in your field. So if you define field and you have inner fields, that values will be copied, and you can have different analysis chain defined for them. And when it comes to analysis, you have those differences in those search engines. You have the standard white space keywords, those pretty simple, but the rest are no longer XML or simple API call, or API calls when it comes to our collection API in Solr. You will need to look into the docs and get used to how you configure your settings for your indices. But that's something that's usually done once, and then once you migrate, you forget about it for some time until you need to change your indices behavior. One thing I would mention here, I have that later in the slides, but as we are talking about, the schema and so on and so forth, remember that OpenSearch by default is dynamic in nature when it comes to the mappings. What does it mean? It means that whenever you send new data to it, a document, it will look into the mappings, and if we see a field that is not known, it will try to guess its type. Of course, we have that in Solr as well, right? But If you start from not dynamic, like in Solr config, it's easy like not to take it, especially if you are used to doing Solr configs on your own. You probably don't start from a dynamic behavior. You do not add this update request processors to your configuration. However, in OpenSearch, you will start with that. This is the default behavior, and it's not really a good idea for production. If you ever like hit a bug or something, and believe me, it happens pretty often. It happens that you end up with your indices being bloated by unnecessary fields, and by default you have 1,000 fields limit per index, and then your data will start to be rejected, which is not something that we want to do. So remember about that. We'll get back to it. When it comes to the definition examples, let's look at how those differ as we are talking about technical stuff. So, this is an example of Solr analyzer definition. So we have a tokenizer, the filters, and so on. Pretty simple XML. If we are working with schema, of course, that could be JSON as well. But, I'm an old-fashioned guy. Let's stay with XML. It's no longer that common to see XML all around. So let's stick with that. In terms of OpenSearch, it's a bit different, though to some extent similar. You can see this analysis chain analyzer. We give it a name and, of course, provide a tokenizer, filters, and so on. So pretty, we mimic just a different setup there, a different format to configure those. We need to shift our mindset when it comes to the queries. That's one of the things we need to remember. So, as we already mentioned, URL versus JSON DSL. The DisMax, so extended DisMax parser in Solr, as the one that is easy to use and at least most convenient. You provide the query fields, you provide the query, you forget about it. At least at the beginning. Of course, I'm oversimplifying things here. But in OpenSearch, multi-match with the best fields behavior probably will give you more or less the same or similar things. We have to remember that filters are different. We have a filter query in Solr. When it comes to OpenSearch, we have the filter element in the Boolean query. So this is kind of a difference. I know people are used to using like FQ parameter in the URL themselves. In the URL itself, in OpenSearch, it's different. We need to wrap that up in a Boolean query and so on and so forth. And of course, faceting aggregations, common differences when it comes to parameters, right? So we have like rows, start, field list, FL. We have size from and source in OpenSearch. So that's again something to remember. And you wouldn't believe how much time is spent on translating those when it comes to working with the queries. If people do that manually, are not really used to OpenSearch, that may be a thing that slows you down, and you would rather focus on the different things like tuning the relevancy or improving your search performance rather than just pure translation, which doesn't give much benefit. And to give you just an example, an old-fashioned nice query in Solr, a DisMax, a query for laptop, def type, so which parser we use, and a query fields, title with a boost of 2, and a description. When it comes to OpenSearch, we have a similar query here. So we have a query, the top-level query that's of type multi-match, and it has a query of laptop, the same as we have the Q parameter, and finally the fields, and so on and so forth. So again, a similar thing, just a different representation. However, OpenSearch queries tends to be way more verbose. So this is one of the things to remember. Faceting example, for example, a field faceting, so the one that gives us information about number of documents with the same value in a given field. So we turn on faceting here. You can see facet equals true, facet field brand. So on a brand, and of course, give me like 10 top brands from the query, and you can expect, Louis Vuitton and so on and so forth in this e-commerce site, for example. Similar behavior from OpenSearch, AGS as the section for aggregation, brands, which will be the name of the aggregation. This is one of the main differences. You tend to put the aggregations with the name. You can get back to them later and so on and so forth. So it's represented in the response from OpenSearch as well. And then we have a terms aggregation on a field, brand keyword, and size. You may notice that I use the brand keyword here because usually, on OpenSearch, we have those fields section in the mappings that allow us to specify different types of analysis, and usually have, like, for example, brand for searching, and then inside it a keyword subfield that is tokenized by the keyword tokenizer. So prepared for efficient aggregation, usually using doc values to not overload the heap memory and so on and so forth. So difference in filtering, as we mentioned, FQ in Solr timestamp now to -7 days, right? And in OpenSearch, we would have to put that, of course, in a Boolean filter, but just to simplify here we have a range query that would do the same limiting. So timestamp and so on, greater than equals now -7 days, lower than equals now. So we have those results ready. And let's talk a bit about migration strategies. So, once we have the configuration done, we need to think about what we can do in order to migrate. Not all of us has the possibility of just, reindexing from source and move and so on. However, let's talk about two obvious scenarios here. First of all, dual write with the historical catch-up, right? So we have our Solr cluster still being there. We have our OpenSearch cluster that we just spin up, and we write to both, to Solr, to OpenSearch. Of course, that requires changes in the application that is indexing, or if you're indexing using an external tool and so on, it requires the changes to the tool or configuration changes only, depending on what you use. Then you may reindex historical data in the background to fill up the index and to be on par when it comes to the data, and then you are ready for any kind of A/B testing, load testing, comparisons, and so on. This is the most I think beneficial scenario that you could take. It requires, in some cases, complex changes to the infra, and not only infra but your application. So potentially, if you are not using any kind of queue, you may want to add, for example, queue before indexing the data and read the data from the queue in order to index, and in order not to lose the data to any of your services. It may also require changes to your application that use the search engine to do the A/B testing, right? But that allows you to do the most not efficient, but the most thorough testing of what's to happen when it comes to your new cluster and OpenSearch migration. It also allows you to gradually move users. For example, start with 1%, then 10%, 50%, and so on and so forth, and scale the cluster. If you can afford that, that's the way to go. If you can't, then, of course, with the planned downtime and simple changes, you take the snapshot of the Solr data, you export the data from a source of truth, use the bulk indexing to load the data to OpenSearch and compare the results there. However, it may require downtime if you're indexing regularly and in a constant manner. and finally, this may be not accepted by the business, which is one of the most important factors, by the way, that will give you either go or no go, depending on the requirements, depending on your analysis, and so on and so forth. So those two simple, and of course those are not the only ones. There are multiple strategies that you can choose for, and BigData Boutique is here to help in terms if you would need any kind of migration strategy help and so on. So do not hesitate there. We also have some performance tips for those migrations. Think like test for optimal bulk size. So we do want to send documents not one by one. If you are using Solr, that's not the best solution for indexing data, especially if you are for throughput, like reindexing the data. You need to carefully choose the size of your bulk. Usually less than 100 documents. Of course, that all depends on your size of the documents. Let's assume that they are like average size, 1 kilo, 2 kilos, and so on. So if they are like this, below 100, you'll probably hit a bottleneck with your network. So it will take a visible amount of time to open a socket, send the data through the socket, do the acknowledgement, and so on and so forth. You don't see that from your application usually because you are not opening the sockets manually. We are not used to doing that anymore. But that's what happens in the background. And we have to be aware of that. Above 5,000 documents, you may start seeing issues with your memory. So the bulks may start be rejected in OpenSearch because of the memory pressure. That's something to see. And of course, additional things like set the refresh rate to refresh interval to -1, not to refresh and reload the index during indexing operations, because this is something that will slow down indexing. Usually you won't be to just index and forget about it and then catch up. Use multiple indexing threads. That will be beneficial. So do not limit yourself and your indexing application for one thread. Use multiple. If you have multiple sources, index in multiple threads and so on, that will be beneficial. Watch out for JVM heap, because you don't want that. And finally, of course, think about all of that and use any kind of monitoring. We'll think about OpenSearch and Solr comparison, Itamar. I think there are some resources. Maybe we can put something there. So and when it comes to post-migration optimizations, there are some things. We'll share this, but I won't be discussing that for now. But keep in mind that there are options, and also we have a very nice blog post, by the way, on that. Just what I wanted to say. One thing. Remember about your shard size. The things that you kept for Solr is still the same thing that you keep for OpenSearch. Keep your target shard size under control. I/O is still precious, and you still need to not fall into the trap of too much waiting from the CPU on the resources like I/O and network and so on. If you have read-only indices, forge merge them. I did a presentation some time ago when it comes to Solr and force merging, how it affects. You can find it on YouTube. So again, it discusses how this affects your overall performance. We talked about dynamic mapping. So use index template, pre-create your indices. One of the things, if you have a lot of indices, for example, time-based data that will be created quickly, in a given time frame, for example, every hour, pre-create them so that the current master node on OpenSearch is not overloaded, and the queue of the operations can smoothly process those, and so on. And save space, keep only the fields that you need. I think I'll just mention one thing. There is a series from Itamar, OpenSearch for data and platform engineers. You can find it on BigData Boutique YouTube. It's a series, I think, Itamar, correct me if I'm wrong, but I think it's eight videos, if I recall correctly. And you can learn about operations and so on. So I'll just skip on that. And
for videos, and yeah, you guys can find it on our YouTube channel.
So yeah, I think we hit the time. Okay, thank you for listening. Hopefully it was that's something that you were interested, and you know where to find Itamar. You know where to find me. Yeah, hit us.
Thank you, Rafał. It was a great session. We didn't have a lot of questions live, but feel free to reach out to us following this session offline for any further questions, and always happy to discuss those topics. Thank you, Rafał, for your time, and see you in the next webinar.